Well, hello, guys. So, right now, I want to talk about server room power consumption. You ready for it? So, we've got a world these days that's dominated by internet enabled technology. Data centers are the brains keeping the digital ecosystem afloat. Responsible for processing, storing, and transmitting data, server rooms are of enormous value, and by extension, so is the infrastructure and the resources used to maintain them. Now, the lifeblood that makes all digital systems possible is electricity. Yeah, and data center managers couldn't be more aware of this, because besides managing a fleet of servers and equipment, the electricity bill and power allocation are essential considerations for server administrators. So, given the scarcity and environmental impact of fossil fuels, organizations continue to consider sustainable energy sources. With innovation and specialization in server technology, numerous organizations choose virtualization or co-location data centers, and these offer even more flexibility. So right now, we're going to have a look at server room power consumption, how organizations approach power needs, and the components using power, as well as the trends in power consumption by data centers. Now, data centers, like most realms of technology, require meticulous attention to detail. Without granular visibility into module and equipment inventory, estimating power needs can be inefficient, costly, or even unmanageable. So, starting with equipment specs, administrators extract the amp requirements for the entire server room. With the total amps needed in mind, the administrator can install power appropriately and then determine the number of PDUs, or power distribution units, needed. So these PDUs offer distributed power to multiple racks or modules. But unlike a standard power strip, a PDU is fit for network connectivity, environmental monitoring, and remote access. Because rack servers can vary in power needs, placing server locations with appropriate power sources is essential. The more powerful the server, the greater the power density is. So this means more wattage, more extensive circuits are needed to manage the additional power and cooling. Have you seen this formula? High density equals energy plus cooling demands. So this power density is a term that describes the amount of power that can be supplied per rack and extends to the capabilities of the entire data center. Now, previously quantified in watts per square foot, the past metric actually failed to account for the number of racks and cabinets, prompting the adoption of kilowatts per rack, abbreviated as kW/rack. So with low demand for data center resources before the, I'd say, 1980s, power density wasn't really a priority, and high density was considered as little as 2 to 4 kilowatts per rack. But today, depending on the data center, of course, some racks can hit as much as 20 kilowatts, while the average is pretty much closer to 7 kilowatts. Now, naturally, as demand for data centers rose and continues to rise, a critical challenge for high-density server functionality is cooling and ventilation. Solutions in progress to meet this demand include liquid cooling and sustainable free cooling using green energy sources. Starting with a needs assessment, administrators can estimate power needs from existing and forecasted equipment. Knowing the sufficient power needed to power critical loads, maintain cooling and ventilation, and more. Data center equipment includes servers, lighting, environment controls, fire suppression systems, security alarms, surveillance cameras, sensors, air cooling, and ventilation systems. So as an example, I'll show you a breakdown of a standard data center's electrical requirements. The cooling system takes up about 50% of the power. The cooling mechanism is for maintaining adequate conditions. Critical loads takes up to 36% of the power, so using equipment nameplates to tabulate base loads and considering future loads based on additional capacity. 11% would go to the UPS modules, so the UPS efficiency and battery charging for redundancy. And 3% of the power goes for lighting. Lighting for the server room is typically 2 watts per square foot. Not so bad. So making up 86% of our example data center's electrical requirements are the 2 most important indicators in calculating server room power consumption. So we're talking about total critical loads and total cooling loads. Smaller but vital to continued power, the uninterruptible power source, or UPS modules. These offer redundancy when the main power source fails. Now, like I told you before, data centers are indispensable these days, especially when considering their capacity for colocation services, cloud solutions, and compliance assurances. So the concern remains whether the value of the energy burned merits the benefits. So in 2017, global data center power consumption totaled 416 terawatts, or approximately 3% of global electricity, with American server rooms consuming 90 billion kilowatts. So meeting these huge demands has prompted some of the biggest cloud providers to design custom servers and chips. Advancements in data center management from the mid-2000s have made a big difference in efficiency. According to analysts, server room power consumption dropped by as much as 80% with the adoption of low-power chips and SSDs. Data center and colocation vendor vExchange offered the following tips to improve data center energy consumption. Eliminate cooling dependencies by cleaning up workloads, eliminating unnecessary equipment. Test different temperatures to understand the most efficient degrees and cut costs. Orchestrate server capacities and loads to meet requests in real time. Detect and squash zombie servers that are running with no existing use. Optimize or decrease space, knowing it can inflate cooling costs. Develop stronger supplier partnerships for mutually beneficial relationships. You see, server rooms require immense power and a level of reliability and performance that keep data online and available for high-intensity use. Adopting sustainable energy consumption practices can offer more visibility into a primary expense and reduce the overall energy burden. Now, despite accelerating digital information services in the last decade, global data center energy consumption only rose by 6% between 2010 and 2018. Energy and environmental think tank Energy Innovation points to these 3 factors for this plateau. The improved energy efficiency of IT devices, servers, and hard drives. Server virtualization software, where multiple applications can run on one server. Compute instances migrated to large cloud and hyperscale data centers, where ultra-efficient cooling is available. Most analysts are forced to use methods based on limited publicly available information in order to calculate the global server room power consumption. While some organizations like Google, Apple, and Facebook report such data, a lack of insight into the worldwide industry has generally led to estimates far higher than reality. Relative to driving, flying, and coal-sourced energy, data centers operate way more efficiently. Now, for looking ahead, intensive workloads posed by AI and machine learning could mean less efficiency in the coming years. Investment in R&D for high-powered computing, storage, and cooling technologies, as well as energy-efficient power, are essential parts of this global puzzle. Less costly and certainly less time-intensive than building a private data center, Co-location centers are shared facilities where renters share costs. While organizations using co-location for server hosting naturally have less physical control over their modules, data centers continue to improve remote control capabilities. From the home office or workplace, administrators can manage a suite of servers from even a continent away. So co-location is a scalable solution that addresses the limitations of private data centers and provides higher levels of bandwidth than the average office server room. Co-location centers tend to be more reliable, considering they specialize in server management like data backups and low-latency network options. An added benefit is the extent of physical and environmental protections. Built to withstand co-location, data centers include CCTV monitoring, private suites, and suppression systems. To be virtual or not to be virtual? That is the question. Cloud-based solutions might offer a similar service, but at the cost of having less control of the peripherals for the server, storage, and network elements. But like most cloud offerings, organizations are responsible for a fraction of the setup that a private data center or co-location center would need. Now, while the trends of the last decade preach the power of the cloud, public cloud vulnerabilities cannot be ignored by IT professionals. And certainly enterprises seem to be leaning toward maintaining at least some on-premises infrastructure. Oh, hey, but guess what? We're going to wrap it up. Now you know all about server room power consumption. I know you learned a lot, so take a break. See you next time.